Hello everyone. Today we'll be learning important topic line codes. The line code is which converts digital data into uh, waveform which is suitable for transmission over a communication channel. There are many advantages of line codes. It is efficient for which is very efficient for transmission and which provides the synchronization and for detection of error it is easier, which also provides immune to noise. There are different types of line codes: unipolar, non-return to zero, polar, non-return to zero, unipolar, return to zero, bipolar, return to zero, and Manchester code. Now let us see how the question will be asked in this line codes. For the data stream 011010001, draw the following line code waveforms. Let us see the first type, unipolar, non-return to zero. So the data stream given we will write, and we can mark 1 bit duration, equal 1 bit duration we have to mark first. In unipolar non-return to zero, symbol 0 is represented by a 0, symbol 0 is represented by 0, and symbol 1 is represented by 1. Here 0 and A we are mentioning. A is the amplitude, that is either 1 volt we can take or 5 volts, it depends. So now let us start marking waveform for the unipolar non-return to zero. Unipolar means only one polarity, that you need to remember. One polarity, only one polarity. That means symbol 0 is represented by 0, symbol 1 is represented by 1. So we can see that 0 is represented by 0 and symbol 1 is represented by 1. For the 1 bit duration, again we have bit 1. So again symbol 1 is represented by 1. Next is symbol 0 is represented by symbol 0. Symbol 1 is represented by symbol 1. 0, 0, 0, 0. Symbol 0 we are represented with 0, 0 and symbol 1 by 1. Now let us draw this for unipolar non-return to 0. Unipolar is only one polarity we know. Now I have taken another data stream 11001010. For unipolar non-return to 0, 1 is represented by symbol 1 is represented by 1. I have marked the 1 bit duration equal. So here I am going to draw symbol 1. So here again the next symbol is also 1. So it is 1. Polarity is 1. Next is symbol 0. Symbol 0 is represented by 0. Symbol 0 is represented by 0 again. Now symbol 1. Symbol 1 is what? Polarity 1. Symbol 1 is 1 represented by 1. Symbol 0 is 0, 1. Symbol 1 is represented by 1. And next symbol 0 we have symbol 0. So this is unipolar non-return to 0. It's very simple. You should remember unipolar means only one polarity. Symbol 1 is represented by 1. Symbol 0 is represented by 0 polarity. Now let us see the next type. Next type is polar non-return to 0. In polar non-return to 0, there are two polarities. Symbol 0 is represented by minus 1, symbol 1 is represented by plus 1. So here we have marked amplitude levels. Minus A plus A is the amplitude levels. Okay. So polar non-return to 0, we have symbol 0 is minus 1, 1 is plus 1, 1 is plus 1, symbol 0 is minus 1, symbol 1 is plus 1, symbol 0 minus 1, symbol 0 minus 1, symbol 1 plus 1. So let us draw for some other data stream. Let us draw the polar non-return to 0. So here we have data stream. We have, this is the data stream. Symbol 1. Symbol 1 is represented by plus 1. Positive polarity. Again we have symbol 1. So it is plus 1. Symbol 0 is minus, here minus A. Again we have symbol 0 minus A, and symbol 1 we have, that is plus A or plus 1. Next symbol 0. Symbol 0 is minus 1. Symbol 1 is plus 1 till the next time bit duration 1. Next we have 0. So symbol 0. I hope this is clear. Polar non-return to 0. 2 polarity. Symbol 1 with plus A. Symbol 0 with minus A. Next we will move to the other type. Unipolar return to 0. Here unipolar already we know that it is only one polarity. But what is return to 0? See, we have seen non-return to 0. Next this is return to 0. See, the non-return to 0 and return to 0 is, for example, 1 bit duration we have. This is 1 bit duration. 1 bit duration we have. Non-return to 0 means one complete duration. 1 will be there, one complete duration non-return to 0. Return to 0 means before completing one time bit duration, it will return to 0. For example, symbol 1. So here this is t by 2. T by 2 it will return to 0. Return to 0. Half bit duration only it will return to 0, that is return to 0. Non-return to 0 means till completing 1 bit duration it will not return to 0. Complete 1 bit duration. Return to 0 means when t by 2 half the duration only it will return to 0. Now let us see unipolar return to 0. In unipolar return to 0, symbol 0 is represented by 0. Symbol 1 is represented by return to 0. Symbol 1 is by 1 for the half duration, 0 for the another half duration. That is return to 0. Completing 1 bit duration, it will return to 0. So similarly 1 is for half duration 1, another half duration it is 0. Return to 0. It is returning to 0. Next again we have 1 for half duration it is 1. Another half duration it is 0. For 0 it is 0. For 1 half duration it is 1. Another half duration it is 0. 0 0 it is 0 0. For 1 half bit duration it is 1. Another half bit duration it is 0. Unipolar only one polarity it is having. Symbol 1 1 but return to 0 and symbol 0 is 0. Now let us draw unipolar return to 0. For this another data stream. Here unipolar return to 0, we have symbol 1. Symbol 1 is what? Return to 0 means, see, half duration I will mark it here. Reference I will mark half duration here. So now half duration it is 1, another half duration it is 0. Again we have 1, so half bit duration it is 1. Return to 0, it is returning to 0. So symbol 1, symbol 0 is 0. Symbol 0 is 0. Again we have symbol 1. For half bit duration it is 1, another half bit duration it is 0. Return to 0. Before completing 1 bit duration it is returning to 0. Next symbol 0 we have, it is 0. Symbol 1 again, half bit duration it is 1, another half bit duration it is 0. Then symbol 0 is 0. This is unipolar return to 0. Next we will move on to the another type of line codes, that is bipolar return to 0. See here bipolar return to 0 means it will have a two polarity. Bipolar return to 0 is also known as alternate mark inversion. Alternate mark inversion in the sense alternate one polarity is changed. Alternate one's polarity is changed, but for symbol 0 it is 0 only. For symbol 1 alternate one's polarity is changed. That means for first one it is positive, the next one alternate one it is negative. This is opposite it is. So now negative, next one it is positive, the another one it is negative. Always first one we should start with positive polarity. Now let us see bipolar return to 0. See symbol 0 is represented with 0 and alternate ones are represented with the opposite polarity plus 1 and minus 1. But first one we have to start with positive polarity. So symbol 0 is represented by 0. Symbol 1 is represented by half the duration 1, another half duration 0 because it is returned to 0. Next one is alternate mark inversion, plus 1, now minus 1. Next one we have to represent it with minus 1, but half bit duration only it is minus 1, another half duration it is 0 because of return to 0. Next one is, say, opposite of this polarity. Now -1 we have represented, now +1. Till when? Only half duration, because it is written to 0. Symbol 0 is 0, 0, and symbol 1 is like alternate mark inversion. Positive we have represented, here negative -1 we have to represent half duration, another half duration it is 0. Now let us write another data stream bipolar return to 0. So now let us see here. So first one is symbol 1. Symbol 1, first symbol 1 is represented with positive polarity. Since it is written to 0, of the duration it will return to 0. Next we have another one, alternate one. So it is of the, this is 0, this is 0, 0. So one symbol 1 we have completed. Now one more symbol 1 we have of the duration, but alternate. This is -1 of the duration, then 0. Next we have symbol 0. Symbol 0 is 0, 0, 0. Now we have symbol 1. Since it is -1 we have represented, half the duration we have to represent +1, and another half duration it is 0. Next we have symbol 0 is 0. Next we have 1. So this is -1, because positive already we have represented. Of duration it is -1. Symbol 0 is 0. So you can see that alternate ones, positive, negative, alternate mark inversion it is called. Hope this is clear to everyone. Next we will move on to the Manchester code. In Manchester code, symbol 0 is represented with -1 for half duration, +1 for another half duration. Symbol 1 is represented with +1 for half duration, another half duration -1. So let me show for symbol 0 and symbol 1. Symbol 0 in Manchester code, how we are representing is, for example, 1 bit duration. Let me take half of this is 1 bit duration. Half of this is this. Symbol 0, how do we represent? So let me take a reference -a and +a. Amplitude we are representing. 0 means it will start -a and like this for symbol 0. Symbol 1 in a Manchester code, how we are representing is -a and +a. And this is 1 bit duration, and this is another half duration. Symbol 1 means +1 first half duration, -1 another half duration. It is like this. So now let us see for the symbol 0. See, start with half duration -1, another half duration +1. Since symbol 1 plus half duration +1, another half duration -1. Symbol 1 plus 1 half duration -1, another half duration. Symbol 0 half duration -1 and +1. Like this it goes. Let us draw this for the another data stream. Then it will be clear it will be clear. So here symbol 1. Symbol 1 start with +1 for half duration. So let me mark half duration. This is 1 bit duration of duration I am marking of duration. Okay, anyway. So for +1, symbol 1 half duration +1, another half duration -1. Before reaching here, next we will see the successive next symbol we will see, then only we will start drawing it. Okay, waveform. Now symbol 1. Symbol 1 means +1 for half duration and -1 for another half duration. Symbol 0 start with -1 for half duration, +1 for another half duration. Again we have symbol 0. So it is -1 for half duration, +1 for another half duration. Next we have symbol 1. Symbol 1 is +1 for half duration, -1 for another half duration. Symbol 0 we have -1 for half duration, +1 for another half duration. Now we have symbol 0, -1 for half duration and +1 for another half duration. It is It is like this. I think hope this is clear too. Thank you.